Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. Super, and today's focus incident, we're going to be looking at an incident with Azure Open AI. This issue predominantly affected the East US 2 region. However, there was some impact to 3 other regions in the United States as well. This impacted customers for around 4 hours, and it occurred on the 9th of May this year.
That's right. So to talk us through the impact and our learnings from this incident, I'd like to introduce the engineering leaders who are joining us on our panel today. We've got Sid Siddhartha, our Vice President and Engineering Manager from the Azure AI platform. And on the end, we've got Hemant Kumar, our Partner Group Engineering Manager, also from the Azure AI platform.
Super. And Sid, just before we get into the incident itself, I was hoping you could walk us through the Azure OpenAI architecture. Clearly, load balancing and traffic management was an issue in this. Could you walk us around how the service should be load balancing and managing traffic?
Even before I talk about routing, I'll just spend a few words talking about what the service is. So the Azure Open AI service, as our customers know, is a platform where we host the latest and greatest models from OpenAI and other open source models at scale. This is a very fast-growing service. And we have a few different flavors of the offer. We have a pay-go offer, and we have a provision throughput offer for customers who are looking for latency SLAs. If I subdivide it more, we have global offers, and then we have data zone, and we have regional. Global is the most flexible in terms of regions offered, in terms of quota limits you get, but data zone is a great option for customers who have regulatory requirements or other requirements. Now, as all of us know, GPUs are high in demand, and we sort of take them wherever we can. And Azure is spread all across the world, and we want to ensure the best latencies for our customers using all the GPUs that we have. So depending on the kind of request you make, whether it's global standard or data zone, we have a set of backend GPU regions to which we route the request to, because we are trying to optimize the best latency experience, both in terms of time to first token and time between bytes for our customers. So if I look at it from a optimization problem point of view, we ensure that the requests from the customers reach the best backend region given their offer in terms of the lowest utilization of these GPUs, so that the customers get the best latency, both in terms of time to first token and time to byte. So that's the role of the routing in this very important service.
So I want to understand that a little better, because that's helpful. A lot of people, when they think about deploying cloud services onto Azure, they think a virtual machine. And for a virtual machine, I get to pick what region it lands in. Maybe I get to pick what availability zone it lands in. But for OpenAI, it's a little bit different here. So you're saying you either say, trust us, put it anywhere you'd like globally, or you say, keep me within this data zone. That's like a data residency boundary?
That's true. So just to we have data zone and we have regional as well. So a data zone is in US and EU. So I know a lot of our customers have regulatory requirements of either being that their traffic can never leave the EU boundary or the US boundary. So we respect that, because that's the strength of Azure in terms of enterprise promise. But at the same time, I know we have customers, for example, in Japan or Southeast Asia. So for certain models, we do offer regional endpoints as well. Like if you create a regional endpoint in Japan, it will never leave Japan. But at the same time, the reason we opened up this global product is because customers are increasingly looking for higher limits, and GPUs are sort of very constrained, as all of us know. We were able to give much higher throughput limits, and the cost is also lower on the global standard offer, just because we are able to utilize this wider pool of GPUs around the world. So that's sort of that's why it's a bit different than your standard Azure service, where it's pinned to an exact data center even.
Pinned is a good way to think of it. Okay, so if you can be unpinned and say, just trust us, let us make the right decision for your customers, for your latency, then there are benefits to that.
Absolutely.
Okay, great. So that's a good kind of understanding of the architecture here. Hey, Matt, maybe I'll turn to you now. So if we fast forward to the 9th of May on the fateful day of this incident here, before we even get to what caused the issue, I'd like to understand how it impacted customers. Can you talk to us a little bit about what pain was felt and for different customers using different configurations?
Sure. Yeah, as Sid mentioned, like we use heavily kind of global fleet to serve customer requests. During this incident, we were limited in what capacity we used, and we'll go into more details about that. But in terms of impact, the customers saw fairly high latencies, up to 20x what their usual latencies would be in this East US 2 region specifically. In addition to that, this global load balancing stopped working in a few regions. And we'll talk about some of kind of the whys behind it. But it did impact in other regions per our earlier communication. And the impact was about 1.5 to 2x of the regular latencies, which was well within the operational thresholds of the service for other regions.
That's helpful to understand. So we really think of this as an outage for ECUS 2 because some of those latency got so bad that it was even timing out, right?
That's right.
That's not just performance issues, that's an error.
Actually, that's a very interesting point that you raise, because to us, it presented as a latency issue. Now, from customer point of view, when they're making a request, they do set a timeout on their side because they expect for their use case, they expect a certain latency bound for their customer experience, for their scenarios. Now, these often expire, and we saw a huge increase in those during this incident. So for the customers, it did present it as service not being available. Even though the experience was degraded, they couldn't make their use cases work.
Right, right. And is that true? And I know we talked about ECUS 2 as being the most impact here. Those other three regions, East US, North Central US, and West US 3, same kind of thing? Would they still have got timeouts or errors? Or
no, we didn't. Actually, that is what we revisited after the incident. In the fog off incident, we observed increased latencies across multiple regions. But when we look at the customer impact, and a really good signal for that is just the number of timeouts and disconnects that we see coming from customers. And those were particularly concentrated in East US 2, and we didn't see like any material numbers increase in other regions.
Great.
I'm interested to know, we spoke about the trigger event for this being a configuration change. This configuration change went through our safe deployment practices where we kind of stage and we gate things to make sure that there's no impact before it goes to multiple zones or multiple regions. In this one, we used safe deployment, but there was still impact. And again, albeit minor impact to multiple regions, but did we miss something in our safe deployment? We didn't catch this. Could you talk us more about this trigger event or this configuration change?
Yeah, absolutely. So as we talked about this, the whole global routing that we talked about is a central piece to ensure the customers are getting the best latency possible. And that's really the reason why we are able to serve so many customers at scale at very low latencies, that customers are able to build such cool applications for their own customers. Now, there are various signals that go into this routing algorithm. And one of them, for example, is the GPU utilization signal, like how busy are these GPUs? So as part of this release change, this signal, there was a degradation introduced in this signal. And the degradation was a certain drop in quality of the signal. It was not like it went to zero. And as you mentioned, safe deployment is inherently to the core DNA of Azure. And we absolutely follow that as well. So we first released to test regions, then we released to regions with lower impact, with lower number of customers and traffic. Then we go to medium regions, and then we finally go to our hottest regions. So while in retrospective, we do see variations in latency in the lower and medium regions, it was not at the threshold where our monitoring or alerts would have fired as they were configured currently.
Right.
And even in the higher impact regions, East US 2 was the most impacted, even though we have other regions like Sweden, which are equally busy, but they did not see that level of impact. Yeah, and essentially, in a nutshell, what happened is because of this degradation of this utilization signal in East US, instead of routing more requests out to a more wider fleet of GPUs that we have available outside globally, we ended up restricting the requests to already overloaded GPUs, which caused, unfortunately, this high latency situation.
As a quick follow-up question, this wouldn't have impacted all customers then? Because we spoke earlier about the two different types of customers who want to be pinned and customers who are saying, hey, you can route my traffic anywhere. Would both of those types of customers experience the same type of impact, or would it have been different for those different types of settings?
It would have been different, slightly different, but in this particular case, so there is some overlap, and in some cases, both these customers would be impacted because their utilization signals were degraded, right? Like I mentioned, in case of global customers, we have more flexibility into sending them out wherever. But in this particular case, because of the degradation of utilization signals, they stayed near East US2, and we did not send them out fast enough.
So just to add to what Sid was saying, like any customers who had provisioned in East US2, what we missed was the signal of, or what got lost with the regression was really the signal of what's the data boundary. And with that data boundary is associated the utilization. So that data boundary tells us, okay, how far can we go? Where should we route this traffic? And without that, we default and fail back to the local region to make sure we are in the most constrained setting possible. So the failback, essentially, any kind of offer that was in East US2, any traffic coming in East US2 stayed within East US2. And part of the reason why the impact was asymmetrically large in East US2 was the fact that the supply and demand mismatch was the highest in that region as opposed to any previous regions that we had gone to.
Got it. That's helpful to understand. So rather than say, oh, this region's really busy, we can move them anywhere we want, because the signal didn't have that data zone information, you thought we better not. So let's better just be safe and keep them closed. That's really good to understand. Okay, so now we've got an understanding of the customer pain, what it felt like. We understand the misconfiguration that was rolled out and how that impacted this traffic imbalance. Hemant, can you walk us through the incident itself? What did we do, right? How did we detect this? How did we investigate what was happening? And ultimately, how were we able to mitigate this?
Sure. So I think this is an area that we reflected on as we got through the retrospective. So in this case, we had a low severity alert which fired. We were flighting latency-based alerting effectively. And those were fired at a step through, didn't page an engineer, were to be handled during the business day. But as the change was so impactful and the degradation so severe for our customers in East US2, we started getting customer support cases from customers, and that's when engineering got engaged. That took about 1.5 hours from the start of the degradation. So the start of the degradation, you can see East US2 traffic comes up with the dawn of day. 9 a.m., you see peak traffic, and that's exactly around the time when the latency spiked really badly. So at that point, we started getting customer incidents. We got on a bridge as soon as we had a high severity page. And engineering, within a very short time, was able to figure out that this is the regression. So we went to triage mode. The triage was, we don't see traffic being distributed. Why is traffic not being distributed? We saw the broken signal. We correlated it to the build. We rolled out a hotfix. Basically, we rolled back to the previous release. Now, the interesting part about this is that the signal just doesn't say that I'm busy in this region. It also says, I have capacity in this region. So effectively, in many regions where we had capacity, this signal was also missing. So we had to roll back across all these regions to make sure, one, this region is signaling, the requests in this region carry the signal that, hey, there's high utilization, I need to get out. But at the same time, we need places where to get out to. So both have to kind of recuperate for the incident to mitigate, which is where we push this accelerated rollback.
Super, that makes sense. And then following on the PIR, we spoke about our repair items, our learnings, and the type of things we're going to do moving forward to prevent this. There were three. There's a couple that really interest me. One of them is we spoke about improved canary monitoring and so on. We use our EUAP regions to try and kind of test live customer data because our test environments aren't, it's always great to have customer kind of simulated or real customer data. What are the improvements that we're making in terms of monitoring? Is it just for this edge case, or have we thematized this type of thing and kind of built a class of monitoring for it?
Yeah, so that's a great question. So in general, we don't want to do Band-Aid over just this particular incident. We want to look at a class of problems because, the AI services are scaling very fast and the whole landscape is very, very dynamic. So we want to ensure we build a very resilient system for our customers. So any incident that we have, we want to generalize the repair items and ensure that a whole class of problems are solved. So having said that, we do want to ensure that this particular problem is definitely solved while we take into account the broader class. The first thing is we did have a testing miss and a gap, which we have now identified, and we have added those as part of our runners and monitors in Canary and even in the live regions, so that even slight degradations of the signal are caught in earlier regions. And Canary would be the best, and even if it escapes Canary, at least in the very low impact regions. So that's sort of already done. And we are working towards declaring outages much sooner for latency-related incidents. We already have this in place for availability as we see it already there. So if our monitors would have thought this as an availability incident, we would have declared outage much sooner, and people would have engaged much sooner.
Just in terms of actually that point bears further clarification, because here we saw 503's unavailability less than 0.1% of the traffic saw that. So it didn't degrade to the extent where service was crashing into it. So it didn't present as an unavailability incident for us, which is why our latency alerting, which is automatic, which is connected with our outage monitoring system and alerts, didn't fire and engages sooner.
It's really tricky to fine-tune monitoring because you don't want to overreact to the slightest degradation, because things happen and our systems are built with so much auto mitigation, recovery, and resilience. But it's tricky, right? You don't want to miss it at the same time. It's a tough act to balance.
Absolutely. And just to close the loop on this point of how do we want to generically solve it, we are deeply looking at our load balancing system as well, because all said and done, utilization signals can degrade for a variety of reasons. So the load balancing logic should be able to go back to maybe not the most optimal state, but it should not be degrading to the extent that it did in this incident. So that's a bit harder challenge to solve, but that's something we're taking head on, and we're definitely working on it.
Cool. Yeah, that's great to hear. So some of those new latency and usage signals will be incorporated and fed back into the load balancer logic, so they're all speaking the same language.
Exactly.
Cool. That's great to hear. But one question that we often like to cover, and actually I'll just clarify very quickly because both of Sid and Sammy used the term EUAP or Canary. So our Canary regions, or Canary down the coal mine, are our early user adoption program, a couple of regions that get bits early that customers can opt into in some situations. So good to know that we're using some of those signals here. In addition to talking about our own learnings, hey, here we at Microsoft, here's what we're going to do differently. We always like to use these sessions to help customers who use our services figure out how to become more resilient themselves as well. So I'm interested here, maybe it's not as relevant given that this impacted multiple regions, but Hemant, could you talk us through kind of the multi-region guidance that we give customers? What are our best practices for customers to be resilient to individual regions having issues?
Yeah, I think that's a really good point. As we retrospected on this incident, it was quite clear that the incident was in East US2 region, localized to East US2 for the most part. In other regions, the degradation was well within the operational threshold, so customers would not experience any issue. Any customers in those regions wouldn't experience issues. So I think the guidance that typically we follow in Azure ourselves is also to base out of multiple regions. So how do we create resources and use multiple regions, use kind of the compliance or the threshold boundaries that we have to have more kind of spread our footprint, so we are not impacted by a localized issue. That is the general guidance. I think that that can build more resilient systems, especially as AI becomes front and center in production scenarios.
Yeah, just to add on to that, and especially a lot of our customers do use the global offer, just because of higher limits and cheaper and all that. Like an example is you could always have two endpoints across continents, especially if you have customers in Europe and US. That's always like a practical example of being able to get your services more resilient. Yeah.
Hemant, I had a follow-up question. Earlier on, you said something which piqued my interest. You said for customers who are more or less sensitive to latency, do customers have a dial where they can configure their timeout so that they say, listen, it can take 5, 10, 20, 30 milliseconds, minutes, I don't care.
Yeah.
And with customers' experience, do they have control over the latency that they're allowed to kind of endure or not?
They control it in the way of timing out their requests.
Okay.
So in the API form factor that customers typically use, they specify the timeout.
Okay.
So depending on the use case and kind of the request shapes, different request shapes take longer or shorter times. And our customers flight these requests and understand what timelines work for their use cases and kind of the prompts they use. The bigger the prompts, the longer it takes. The more the generation, the longer it takes.
That's interesting.
And so customers optimize for these in the context of their use cases, and it's quite variable. And so one of the key things that they do to control what works for their use cases, for example, in chat use cases, customers use streaming. They are a little bit tolerant to up to 0.5, 1 second of initial delay, but soon after, they expect a steady stream of bytes coming through. And they would time out the request if the request goes on for too long, because it directly impacts the yield. So yeah, they control it. It's slightly different than many other services, like for example, databases, where you have very, very standard timeouts because you have a very targeted use case. Here, there's more flexibility.
Yeah, and just to sort of pile on to that, unlike a more traditional service like Cosmos DB or other API, storage API calls, which are very tight latency bounds, the whole LLM landscape depends on a few factors, like how big your prompt is, or how big an answer are you expecting, which model are you calling, is it a reasoning model, is it not a reasoning model? So that sort of makes the whole latency promise slightly more complicated, but we do have in our documentation time to first token and time between bytes, which are the more standardized measures across the industry, but it's a little bit more involved than a traditional service.
That's a great summary. I think it's not just a transaction and a byte.
Exactly.
It always depends. Yeah, that's great to understand. Thank you for explaining us through that. As always, I've saved my last question for my co-host Sammy here. Sammy runs our incident communications team. And so just as Sid and Hemant have been talking us through our learnings from the service team perspective, I wanted to ask Sammy, do we have learnings from the communications perspective? Were we able to keep customers up to date during this outage?
I'm going to rephrase the question as how was comms? And it was mixed. But part of it that I think is painful for our customers, and we don't want to talk about how we followed our playbook, but from the customer experience, it was pretty bad. It took us 2.5 hours to get, after the initial impact, to get communications out to our customers. Part of it was we covered with some of the detection issues and kind of correlating what was going on. It had to be customers who raised support cases because of the monitoring. But once we were engaged, within 2.5 hours, we got 90% of customers who were impacted communicated to. An hour later, we sent out another notification. This time we captured every customer that was impacted, and even a little bit more because we were communicating to customers in the other 3 regions, even though they probably weren't seeing timeouts and they were seeing micro latencies, but we still communicated to them as well, and so they were aware. When we communicated through Azure Service Health, which is the right thing to do. We don't like going to our public status page when we're able to identify customers and communicate to them directly. This way, customers can go into some of the features of Service Health, like potentially impacted resources, and they can see, okay, these are my models that are potentially impacted. We tried to offer ETAs, and we did so as we were coming into recovery. And so I think, again, some of the advantages of using Azure Service Health, really understanding, getting clear ETAs, getting the impacted resource, and so on. We shipped our preliminary PIR with a rudimentary understanding of what was going on. We followed up with our final PIR, and of course with this live stream. So I mean, it was mixed. The delay for customers to hear for customers to tell us about an issue is never great, but we always know that more often than not, customers are going to know there's an issue before we do, but it should be minutes, not hours.
Got it. That's helpful. And some of the monitoring and detection improvements will definitely help on that one as well. So thank you for that summary. Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.